All right, so we're ready to chuck this side right here and go ahead and get it face turned. All of the other features, I've went ahead and added all of the dimensions that I need for the OD and the lengths of all of the shoulders there. I've got our groove widths and groove diameters on there, everything that I need to know to reference there. So I ended up measuring the threads. So the barrel, which was in the previous video that we skinned the thread, I went in there with my calipers, my spring calipers a couple of times, and took a couple of measurements. And what I'm landing on for the OD of our threads here to be 2.7, and that should give plenty of clearance there on the outside of the thread, and then it'll be threaded 12 TPI. So it's really the only feature I didn't really draw on here was the threads themselves. But this is a personal reference just for me to use right there, so I know what I'm going to have to be putting on there. So anyway, there's my sketch. Let's go over and start setting this piece up in the lathe and get it indicated. All right, we already got our forge jaw kind of set where we want to. I'm going to try to hold about a 1/2 inch or so. We'll just kind of lightly get this tightened up and squared up. And I do have what we're going to do. I've got some of this brass shim stock that I call soft jaws. We'll put that underneath there just to help from biting into that ductile iron. But what I want to do is make sure that I've got enough room to go all the way back to where I want to, and we should. This largest thickness on the end is 5/8, so we got plenty of material there. All right. We'll get our soft jaws underneath here, our little pads. Just like that. It's still a little bit crooked. So I think we'll start with the face, kind of get that bumped in a little bit, and then we'll work on our OD. And I'm going to go change this tip out here. This is that roller tip that we use. I'm going to put the other tip back on here. Standard tip back on the indicator. And let's go ahead and get the face bump true. That'll just make indicating the starting to stick a little bit. I need to clean it. Couple of thousandths away. There we go. That's within 1 or 2 thou. Once you get that face bumped around true, and then you can come back to the OD. Indicate close to the chuck jaws. Start with the highest first just to make sure they're not loose. All right, that looks good. I'm just going to take the indicator, I'm just going to move it down here. All right, so we've got about 5 thousandths out. Just finding that high spot, bringing it around to the top so I can just bump down on it. It's just easier. That's within a thou right there. So we'll have to come back to the jaws. You have to do this a few times just to get it straight. This is part of the process. So that's within a thou. So we'll just tighten the high. Tighten it up, but be careful on how much pressure you've got on there. You can see it's already there. So I'm going to make sure all 4 jaws are adequately torqued. We don't want the part moving once we start cutting it. But you do have to be careful that you don't over tighten it and start distorting things. We've got plenty of wall thickness there, so it shouldn't be an issue with us. Just a little bit on that jaw. That looks good. All right, one more time out here. One thousandths. So that's not bad, but let's see if we can get it closer. A little bit. That's a half a thou. I don't think there's anything wrong with that, do you? See, if you just leave well enough alone, it's usually fine. And if you keep messing with it like I do, you'll end up moving it and you got to keep bumping it. But that's just all part of the process. So that's within a half a thousandths right there. That is going to be close enough. Perfectly fine. I am just going to come back here just to check this. And you see it's within a half a thousandth. So we're good to go. We're indicated and we are ready to machine. We'll start with our face. Our finished part is going to be 2 5/16 long. So it looks like we've got about 140 thousandths to take off the face there. I was seeing how straight it faced it. I don't know, 4 or 5 thousandths off maybe. Tell you what, I just like reading a dial indicator, an analog dial indicator. So I'm going to put this guy down here. It just seems to be easier to move an indicator than a digital number up on the screen there. So take 50 thou. Looking for 2" 3/12. 37 thousandths. And that length is not super critical either. We just want to try to make it the same size and make it on a standard size. Gonna zero my Z right there. Go ahead and double check. Let's see if I hit around 2" 3/12. Looks like we got it, 2" 3/12. Perfect. All right, our Z, what we want, let me calculate what our what our distance is going to be. We'll just go to each shoulder length. So the first one's going to be 750, 3/4 of an inch. I've already got my DRO set. I am going to slow this down. I don't want to run it that fast doing this OD. So we'll go to 380 RPM. Change feed direction. And we're taking this down to 2.5 inch nominal size. I have got 2 inch 496 is the diameter that we're going to turn this to. X 3 inches. All right, just take a 100 thou pass. Just going to set my dial indicator here. I told you I like looking at this dial versus looking up at a DRO, because your natural eyesight when you're standing here at the lathe, you're looking down at your tool, and it's a lot easier to look down here at this indicator than to put your eyes up higher. It's just a personal thing for me. And it's always good to keep up with your measurements. 2.8. Go ahead and start miking it. We should be really close now, within about 15 or 20 thou. Got about 20 thou, so I'm going to take 10, slow the feed rate down, get a good finish, mic it, bring it to size. Okay, 8 thousandths. I left 10 thousandths on that face to clean up. So we'll back face it and then set our length for the shoulder, for the next shoulder. 10 thousandths. All right, move that indicator. So what we'll do up here on our DRO, see our next length is going to be 937 thousandths. So we're going to negative 0.927. That gives me 10 thousandths to clean it up. And then we'll take that to 0 for our next shoulder length there. I'm going to go ahead and get my dial indicator set here where I want it. All right, and you can see we've got adequate clearance there between the tool. That's going to be the shoulder minus another 10 thousandths. All right, so we're taking that down to a diameter of 2.7, so we only got 200 thousandths to come off. Should bring us right back to 0 on the dial. Yep. And let's go ahead and mic it. That should be about 2.9. Yep, 2.901. 7, 8, 9. What did I tell you? 200 thousandths? Yeah, I wasn't right. If I said 200, 300 is what I meant. All right, so that should leave us about 100 now to come off. What I'll do is slow it down, the feed rate. Yep, that's 804. We want 700. What I'm going to do is we're going to go up to a different speed. And I am going to slow the feed rate down here. Take about half of it. That 2.7 should give us some clearance in those threads in the barrel. I was measuring with my calipers anywhere from 705 to 710, so that's why I picked 2.7 as our major OD. All right, 755, so we got 55 to come down. 50 and 5. We'll go to that face, clean up another 10 thousandths off of it, and that journal should be finished. Ten thousandths, do a back face. Let's see if we hit our mark. Two point 2.7, can you see that? On the money. Yeah, it may be a tenth over. 1/10 over. Who's counting that? All right, next up, we're going to cut the 2 O-ring grooves. So what I've got for that is I've got this Walter GX style grooving tool. This is 3 millimeters wide, but I'm measuring about 117 thousandths wide. So I've got my math done, so I know what my offsets are going to be. So we'll get it touched off and get these 2 grooves machined. Touch the tool in the face. Our first move is going to be 242. Bring this up to our 0. This will be our first cut, and this is going to give us 1/8 of an inch. Let me get my scale. This is going to give us our 1/8 of an inch there between the groove and the outer face. So we'll make a cut. We're going to offset it the total width that we need for the groove, make another cut, and then we'll come to the center and cut the center out, and then just clean the bottom up to the right diameter. about there, and I can come in here with my scale. That's just a 5/16 wide groove, so I can visually see that I have it right now. It's on 5/16 there. Okay, that should be good. What I like to do too is I take it and I just touch it, and this is another easy verification. Yep, 5/16. All right. Come in here from the backside with my micrometer, since this is such a wide groove, and actually get a measurement here. We're looking for 2 1/8 on our micrometer, so it looks like we're about 3 thousandths over that. But that's within the tolerance, because that's a +6 -0. So what I'm going to do is just clean that up one more time. Just going to go in like another thou. Just make sure it's cleaned up nice. Looks good. Our first groove is finished. We'll come in here and check our width as well. We're looking for 5/16, 312. Get it squared up. What are we, about a half a thou off? That's going to be good enough there. We're lined up for our next groove, so we're going to take that from 2.7 down to 2.5, and then we'll have to offset it 30 thousandths to widen it out to the proper width. All right, I'll do some measuring, make sure that we're on our size, but otherwise that groove's ready to go. Measure that diameter, see about what we hit. 2.5. Right where we need to be. I've already measured the width. We're a couple thou over, but no problem at all right there. All right, so next up is gonna be some, let's cut some chamfers on all the edges there. We'll bevel, so this is gonna be where the thread is cut. We'll do some nice chamfers on that, and then last up is gonna be threading it. For these OD chamfers, I'm just going to use my threading tool there, and we can kick this thing around one notch on the tool post. All right, we're gonna go ahead and cut our 12 pitch thread there. That's the last feature on this. So we've got our machine set up for 12, LBT6V, LBT6V, and we'll go ahead and verify that. Check it with our thread pitch tool, and then go ahead and start cutting this guy. So remember, we are cutting threads to fit this chase thread in this barrel right here. So since this is fairly small, what we can do is kind of sneak up on our pitch diameter on the gland that we're cutting, and we'll be able to just grab this and just make sure that it screws on there, that it's fitted properly. Wanted to point this out again, my technique for doing threading there. I've got the compound set. I've got mine set on 29.5 degrees. Cross slide set to 0. Always come back to that 0. I have a 0 up here on my DRO that I can use as well. And I'll re-zero that once we touch the thread off. So touch it off using the compound, and each pass use compound infeed. Get our compound touched off on the workpiece and set our 0. All right, there's our touch off. This is going to be our scratch pass, and we'll check it. So we're running a nice low RPM there so that we don't risk coming up and hitting that shoulder. That's the main reason we're threading at a little bit slower speed there. So we'll go ahead and back out. I'm going to go ahead and come up here and reset my 0 and then stop it. And take our screw pitch gauge here and verify that we're on 12 threads per inch. And it looks like we are. So we can continue on. Approximate depth that we're going to be feeding in with our compound is going to be about 62 thousandths. Easy formula to remember when you're cutting threads like this. That'll put you really close. 0.75 divided by the thread pitch. So 0.75 divided by 12 is going to give you a calculation of 0.0625. So we'll sneak up on that and start hand fitting it. So that's a depth of 55 thousandths on the compound there. I think this is a good spot to go ahead and give it our first test. A little tricky to get started straight. But I am undersized, so I know it shouldn't go. It's going to take a little bit to get this. All right, I know I'm undersized, so we got to take a little more off that. Now it's trying to go on there. I got it to go on about a quarter turn, and I can just tell that There's just really not a lot of wiggle room there, so we've got a couple more thousandths, but we're really close. I don't want to risk getting it stuck, which is what happens in situations like this right here. Yeah, it's trying to pull on it, so you got to be really careful here. It's best if we use some lubricant on that whenever we go to test this. So we may be doing that, because it is easy to gall that ductile if it's not right. All right, but this is really close. So we're 60 thousandths deep on our compound infeed. So we're right there where I was saying, the 62.5. So we need to take a couple more thousandths and see if we can get it on there. And I think the next couple rounds there, we'll go ahead and spray some penetrant on there, some lubricant to try to eliminate any kind of galling that might happen with our test fitting. Guys, I forgot to hit record on that last chasing pass there, but I went in there and took 2 more thousandths out of our pitch diameter and in a spring pass. So we've got it filed, softened up, so there's no burrs on there. I want to go ahead and give it a little bit of lubricant. We're going to put some of this knocker loose on there and on the inside of the barrel, just to kind of help prevent any kind of galling that it might want to do. Let's give this another check. Picking up on the weight of the cylinder down here, just trying to keep it neutral. It feels like it's wanting to screw in there like it should. Right there, it's not wanting to. All right, I don't want to force it. All right, it's got a spot that it's getting tight right there. All right, so we still got a couple thou we need to take off of that thread there, so we can make sure that this screws all the way down into the barrel. Still a very close fit there, even though it might look a little loose with this barrel hanging off of it. So just taking 2 thousandths at a time. And I do want to point out that I went in there with a mill smooth file, this guy right here, and I went ahead and just gently filed about 5 thousandths off the peak of those threads there, in case I was off on my diameter. It seems like it's wanting to hit somewhere. Remember, we had some damaged threads in this barrel that we had to chase and clean up, and I may not have cleaned up the entire, threading profile. All right, what's going on? While we... I don't think it's starting straight. Got to get it, make sure we get it straight. Okay, there we go. I got the knocker loose on there, and I want to screw this in very gently and don't force it. All right, so yeah, see, it's got a spot right there that it's wanting to catch. Got a spot in there somewhere. I think we need to take another 2 thousandths off of the pitch diameter. I have chased this several times, a couple thou at a time, filed tops of the threads in this barrel still will not screw on there. It's telling me that there's still a little bit of an elliptical shape in those threads. It's not fully cleaned up. It gets to a tight spot in there when you screw it on. It gets to that spot right there. And I don't want to force it on there because I don't want to get it degalled and I don't want it to gall and stick. I can't tell how much further it needs to go, but this is really starting to get frustrating to me because of how much time I'm spending on this thing, and it should just go on there. I'm tired of chasing the threads on the Gland. It's already under what I wanted it to be. I think what I'm going to do at this point is finish the Gland, leave the threads where they're at because they're good. I'm probably going to have to set this barrel back up the way we did the first time in the four jaw and the steady rest, and go in there and chase the threads in the barrel again to try to get those cleaned up. And then I'll have the Gland in my hand to where I can, you know, test fit it. This is where these types of jobs can get very frustrating, this job shop stuff, because you kind of figure about how much time you're going to take to do something and make a new part, and then it ends up taking a lot more time than what you're expecting it to do. And that's when it starts getting frustrating. It should fit together and it's not. And I'm just having to continue working on this thing, and I'm ready to get it finished up. So like I said, I think I'm done chasing threads on that Gland right there. I don't want to take it down anymore. The problem's definitely inside the barrel right here. I somehow did not get that cleaned up nice and round in there. So I think the next step is to set this back up again one more time and see if we can chase it that way to get it to fit. I've got the Gland polished up there and finished where I want it. I am not happy about this in the least. We're taking it out of here, and I'm going to set the barrel up and do some thread chasing on it. I'm not going to film it because I've already shown doing that in the previous video. I'm to the point where I want this job, I want this completed, and it's taken more time than I had put into it, and I'm just ready to get it done. So I'm going to keep messing with this until I know that this thing fits the barrel the way it should. All right. We still got to drill a couple of holes in there for our spanner wrench. We'll get to that too. But I'm going to work off camera trying to get this thing fitting that barrel. And when I get it to that point, bring you guys back so that we can continue on with the job. Okay, we're set up in the milling machine. We're ready to put the holes in here for the spanner. So what we use for this right here, typically when you see the holes in the face, is you use an adjustable face spanner wrench right here. These come in a few different sizes. And this particular one, the number 483, this is made by Martin. This has 1/4 inch pins. So you just need a couple of 1/4 inch holes in there for this to go in. And this is generally all you need to be able to tighten these up and loosen them up, unless it's galled up, of course. So there's the sample. Now what I like to do sometimes is just go ahead and put 4. It doesn't hurt the Gland in any way whatsoever. It just makes it more convenient for the installer whenever you're going to put these things in or even taking them out. Sometimes it's more convenient, just from experience, if you had multiple holes in here to be able to position your wrench in a better position. It makes it a little more convenient. So it won't take but an extra minute to drill those other 2 holes. So I'm just going to put 4 equally spaced in there. So first thing we do is just get it centered up, and then we'll move our do our offset. The center to center on this is 2 3/8. I'm going to use my Blake coax indicator to get this centered up. What I like to do just to get it roughed in, just visually watch that stylus from where it's at and just kind of move the table a little bit to kind of get it equalized. That's all you got to do. All right, and then once we do that, we can go ahead and drop it down in there. Come up just a bit. All right, move the table in XY till we get that needle running 0. I'm going to put this other Noga mag base right here just to create a stop for the stop rod here. Just like that. Just have anything to put against the stop rod. Just moving the y-axis right now. And then we'll move the x-axis. You always got to go the wrong way first, right? Now, you definitely can put the machine, that's where we need to be. You can definitely put it in gear, use low speeds on this. That's what a lot of people like to do. All right, and some people like doing like that. Just let it run and then adjust the table back and forth as you need to until you get the needle running 0. But that's just a little bit too fast for my thinking, my brain. I like the slow and controlled method where I'm watching it 180 degrees, front to back and then side to side, and I just move it as I need to. That's just my preferred way to use it. So there we go, we're centered up. 0 the DRO up here. All right, we got that done, and now we'll get our indicator back out of the way, get our holes drilled. Careful when you come out of these. I don't ever let that stylus spring to a stop. I hold it with my finger and then bring it out gently. For this, we're just going to use a 1/4 inch split point drill, stubby drill. We don't need to spot it or anything. We're just going about a 1/4 inch deep for a spanner hole. So our hole spacing is 2 3/8. Divide that in half. That's 1 3/16. So we'll just move it over to one side. 187, there and about. Doesn't have to be exact. Main thing you want to make sure of is that you're not drilling down into that groove where that wiper goes. And just visually inspect it, but I already did some double checking and we're right where we need to be. And we'll get a depth set. And instead of moving the table all over the place, since we got our spacer up here, I've got my 0. I have a little dot on this front side that aligns with this little ball oiler. So I use that as a 0 reference. So all we got to do is just drill it, move it 90 degrees. This thing falls in place like that. 90, 180, 270, and then 360, or our 0 where we start at. Let's get our first hole established here. I'm going to set a stop up here on my quill. All right. I'm just going to go ahead. We're going to make this like 5/16 deep. So I'm going to set me a stop up here. Just setting this guy up here is what I was talking about. So I've got a full radius established right there, and I've just used my scale to adjust it to a 5/16 depth. Nothing ultra precision on anything like this, just a hole for the spanner. So let's get going on it. All right, let's go. 90. $180. $270. And that's it. 360 would be our 0 where we started. Let me grab our spanner wrench. Just like that. I like drilling those as close to that size as you can. The tighter you can get these pins to fit, the better it is when you're trying to install it. I guess let's go ahead and chamfer it. Break those sharp edges off there. Got a little chamfer tool set up in there, and what I like to do sometimes get it going the right direction, which is reverse. All right, I'm bringing the tool down against the stop on the quill up top here, hard stop, and I'm just gonna bring the knee up until it just cuts and deburrs it. Don't need much, I mean, just a few thou, just like that right there. Now we've got our stop set. All right, we can go ahead and go back to our 0. $90. 180. There it is. They're all deburred. I love my Vertex indexing spacers. Absolutely essential tool to have with your milling machine. All right, well, this guy is finished up now. I think it's ready for the install. I was using this brass shim just to protect the threads. There's no damage to that. It doesn't take a lot of pressure to hold something like that for just a little light drill and knot. All right, guys, we're over here at the hydraulic press. I've got this plate that I machined. This is some 5-inch 1045 little cutoff that I had. And what I did was I bored it. In the center, it's bored oversized for the pin. And then this right here is a counter bore for this tube that's welded on the end of the rod. That way I can set it down in here and it's gonna push flat against this face, but the center will allow the pin to go through there. So we can, hopefully we can just set this down in there like so. I've been soaking it all day in CRC knocker loose. Hopefully that has kind of loosened it up a little bit. The knocker loose actually ran all the way through there, so hopefully it'll press out of there. I got this little pin right here. Got it faced so it's nice and square on the end, and we're gonna use this setup right here and hopefully have a nice easy press job. Easy it is not. I have got some tonnage on that thing. It is not doing anything. There it goes. Oh, man. I was worried that it wasn't going to come out of there. I used to have to bow up on this thing a lot when I was younger, pressing shafts out of electric motor parts. Look at that. Dry as a bone. Well, the old hydraulic dake did it again. I want to show you the fit on our gland inside the tube there. You know, we had to set this back up, and what it was just behind the threads where our O-ring goes in there and seals on the barrel. Because of that slight amount of egg shape to the barrel, there was some high spots in there. So I went in there with a boring bar and just snipped off those high spots enough where our gland could clear. And then once I did that, I went in there with this flap right here and polished it really nicely, softened up those edges and cleaned up the bore right there. I don't have a proper hone to go in there and hone this whole thing out, but I did go in there with some pig mat on a drill over there and some heavy duty degreaser. We got it cleaned out. I visually inspected it. I don't see any scratches in there. Everything looks good. So it's cleaned out well. So we'll give you a test fit. Now I'm always leery about going into questionable threads like that with a brand new part. I have had times in the past when I was in the hydraulic shop that things galled it up. Brand new parts galled it on me and I had to redo it. So I'm just going to use a little bit of this knocker loose here just to kind of help ensure that we've got some lubrication on the threads. A little bit loose first couple of threads there, you can see, but as we get up in there, it starts getting tighter and it's still actually rubbing the barrel just a little bit. So, but we do have a good fit. We'll put our spanner on here. And you can see it'll screw in there. Got a good tight fit once we get all the way up in there like that. When we do the install, I'll put some anti-seize on those threads for the final installation. We've got an O-ring groove cut right behind the threads, and this is how this is designed to work anyway. I think in the past, you know, I don't know how old this cylinder is, but I believe the O-ring deteriorated and it allowed moisture to get up inside these threads there and eventually start corroding, rusting, and causing problems. So we've got we'll have a new O-ring so that it'll seal right here on this bevel and keep the water from going down in there. So we are just about ready to start the install, the reinstallation of our rod, our piston, rod gland, and all that stuff. I think we finally made it to a stage where we're going to start putting this hydraulic cylinder back together. We've got everything cleaned and ready. I've got all my supplies and my tools here ready to go. Got a couple of seal tools over here I was going to show you as well. But we've got the barrel is cleaned out really well. I've set the chrome rod up in the lathe, gave it a little polish. And just for transparency, so you guys will know, there is a couple of scratches in this chrome right here. Typically, this is caused to replace a rod. In this case, customer doesn't want to do that. The rod's still good other than these two scratches. So it's not the way you're supposed to repair a hydraulic, but that's the way we got to do this job right here. So I just want to show. Usually when you find these gouges like this in the chrome, in the rod, you replace it or you repair it having it chromed. In a case like this, you would just simply buy a piece of chrome plated bar stock from CRC and just machine another one, but they don't want to go that route. They just want to use it like it is. So I just want to point that out there, okay? Got the end flapped out there where it was all corroded, and we are ready to go. We're going to start by putting our seals in the new rod gland there. We got a couple of tools. We got our piston right here too. This is our PTFE piston seal. So I got a couple of tools that we pulled out of the box that we're going to be using. For the piston, we're going to use this seal clasper right here. This really helps you get this PTFE seal pulled up around the piston, because this is oftentimes a little bit tricky to get on there and get it pulled up. So we got this little clasper tool right here that we can use to go around the piston and pull that in there tight to help seat that seal in there. So we're going to be using that one to get that done. We'll go ahead and leave that out. That's what it is right here, by the way, seal clasper tool. And then to install our cup seal right here, our rod seal, we're going to be using one of the twister tools right here. In our case, I believe we're going to be using, let's see, on the back it's got information right here. So small, medium, large, extra large. So we're going to be going with the medium gland bore size since we're half bore. That is going to be this red handled twister tool right here. And then we'll take this little guy out to help us as well. So these can be really helpful. They're not necessary for hydraulic repair, but they definitely can make your job easier when you're trying to get these seals down in those rod glands. So again, this is some tools that came from Hercules Sealing Products. So let's get started putting this guy together. Before I get started on the rod seal, what I was going to do was I'm going to put our piston seal right here, just the PTFE part of it, not the O-ring. The O-ring just goes in the bottom of the groove, and that's what the seal pushes on and expands it out. So I'm going to put this in this cup with a little bit of water. I'm just going to put this in the microwave and just let it cook for a couple of minutes to try to get this hot and soft, and then let it just sit in this hot water while we're putting our gland together, okay? All right, so we got our little plastic block mounted in the vise there. This has got a hole, so you could screw this down to a workbench if you want to. I just put it in the vise. We got our medium-sized twister tool. We're going to take the handle away from us in this orientation and just kind of stick it in there. This just holds it for you, okay? Now we're going to take our seal, and we want the lips pointed away from the tool. And we're going to stick it on here just like this right here. All right, you guys see that? All right, and then you got to hold it with one of your hands. We're going to use my left hand here. Take the other handle and just bring it right on around like so. See, this is why you got to hold it, because it tries to kind of move on you. And once you get it, you can pull this out. All right, there you go. Now this is twisted up so that you can easily stick it down into the rod gland and release it. But we're going to do that over here on the bench, okay? Just want to show you how the tool is working right there. All right, now we've got the seal twisted up here. We're going to take our gland. You usually have to work it just a little bit because it won't quite go all the way. It won't just drop in there yet, so you got to kind of work it a little bit. Work it around so that you get it down in there. All right, and then we're going to slowly release. We've got to work it with our hand a little bit more. Sometimes they can try to roll on you when you go to put them in there. So I've got this little spoon tool, a little soft edge tool. I'm going to come in here and just push on that seal lip down there to get it squared up. It just needs to drop in. There it goes, dropped in right there. That's why I machined that bevel on that back side of that groove right there. It just helps get it down in there. So just inspect it, make sure it's not rolled anymore. It's all the way down in there, just like it's supposed to be. Next up is our ST wiper. These are usually pretty easy to put in. Just get one side started and just work your way around. Let's start that over again. There we go. Just work it around, and it usually just snaps right in. Sometimes if the edge catches, you can just take a little tool like that and just push on a little bit to get it to snap down in the groove. All right, so there's our seal, our wiper. Now we still have a couple of O-rings left to put on here. So next up is our tube seal. That O-ring is going to sit right here. It's going to seal against the barrel to keep the oil from coming out. So we start with our 575-330 backup. Just snap it on there, push it to one side. Now we have our 330 O-ring here. Those are usually pretty easy to get on there. So there's your tube seal installed. We have one more O-ring that's going to go here, and that just seals against the barrel to keep rain and moisture from coming down in those threads. All right, here's our final seal it's going to go on. All right, that's it. Last thing that we'll do before we install it, go ahead and take a little bit of our grease right here, our Staplex, and just put a little bit of our grease in there, and then we'll slide it up onto the rod. Just take a clean brush, get a little bit of the Staplex on there. Just grease that seal. Put a little bit on the wiper there as well. Just like that. All right, so we got our rod gland ready to install now. Just work it on there. Once it gets that seal, get a little tight, but there it goes. It just slid right on there. All right. So what we want to do is take some of our Staplex, go ahead and put a little bit on this O-ring here and the backup. Sometimes it's easier if you just spin it a little bit, get it around if you have to. All right, and I'm going to put a little bit on this O-ring here as well. All right, and then for our threads, we're going to go in with some anti-seize. All right, that gland's ready to screw into the barrel now. We have our O-ring that's going to seal the bore through the piston. Get that guy pushed up on there. And we'll take our piston that's got the O-ring groove machined to one side and make sure it's against the O-ring. And that'll squeeze up in there and seal just like that. And then we have a lock nut here. Get that going here and get it tightened up. We'll use Dad's 18-inch crescent. Tighten up our lock nut. Need to reposition this so that it doesn't spin. This is the O-ring that goes underneath our PS 1400 piston seal. Drop it down in the groove. And now we're ready for the seal on top of that. All right, last up we've got our PTF seal. This has been soaking in the scalding hot water for a few minutes. It'll help make it a little softer. And we want to get this guy on here next. All right, we got it straight. All right. Now we'll take our seal clasper tool and clasp it around this, and it'll help squeeze it back down to size. All right, we got our seal clasper tool. We've got it opened up, and we're going to put it around our seal here, our piston. Just kind of bring it centered there, pull it to the top, and now we're going to go ahead and ratchet down on this. Just trying to make sure it's even there. All right, like that right there. So that's got that seal squeezed all the way in. We're just going to let that cook for a few minutes, and then we'll take it off, and that should be ready to install into the barrel. I've got the barrel set up while that clasper is still pulled down on that piston seal. What I wanted to do is put just a little bit of the Staplex grease on the bore in here, right where the piston is going to slide up in here. That'll help get that up in there. All right. And then I do want to put another touch. I know we've got the threads anti-seized on the gland, but I'm just going to put a little dab of this right here on these threads too. Just put a little bit there, and that'll work its way around. Just make me feel a little bit better about screwing that together. You do have a you have an existing sort of damaged thread, even though we cleaned it up, there's always potential for one of those little areas in that thread to start, catching metal to metal as it's rubbing and start tearing and galling. And once you do, you can hang it up. But hopefully it's all going to go together well. All right, let's go ahead and see if we can get this clasper tool off. I'm ready to get this cylinder together. Let's see if I can remember how to do this here. There we go. You gotta you gotta tighten up on it, push the button, and then bring that in, and it'll loosen up on you. All right, that looks good. It's got that PTFE pulled in there nicely. It should go right up in the barrel. And we'll just take some more of our Staplex and go ahead and brush a little on our piston and piston seal. All right, just see if we can get her pushed up in there. I've got my rawhide, my soft blow, because we're going to need to bump it a little bit. There we go. Actually, we got it going. So now we'll get our spanner on there, tighten it up. Adjustable face spanner. Starting to get tight because I can feel that O-ring starting to seat on the barrel in the inside. Reposition it, and we'll take our soft blow hammer and just give it a few hits. Seat it, and that is good. It's still a little bit snug because of this barrel being egg-shaped up in there a little bit, but we got it. All right, guys, well, this job is finished up. My part of it anyway. We've got the hydraulic cylinder repaired. We've got it resealed, got it back together. It needs a little bit of paint, but they can handle that, no problem. Just get a rattle bomb and coat it down real well. So it ended up being more work than what I was hoping it was going to be. And sometimes these jobs like this is what happens. You're trying to help somebody out, trying to save them a little bit of money. You end up spending more labor in it than what you're probably going to get out of the job. And that's the case for this one right here. But I was glad that we could get it fixed and get it put back together. This would have been a case where it would have been nice to just build an entire new cylinder. I wasn't wanting to build a whole new hydraulic cylinder. I was just trying to help them get this Gland built and get it back together. And unfortunately, we ran into a couple problems along the way, but we managed and we got it done, and we were able to save everything else, and it is ready to go. The pin, this is the pin that we pressed out of it right here. I couldn't believe how tight this thing, how bad it was just corroded inside that rod eye. The best that I can measure it, this is actually 32 millimeters, which is another surprise because you have inch sizes with the rod, the Gland, the seals, and the barrel. And the best I can measure, this is 32 millimeter. And the rod eyes down here, these tubes are measuring like 33 millimeter. So a little bit of a morphodite setup. And they said that, this is not an available cylinder anymore. You can't buy this exact cylinder, but what you can buy is a cylinder of the same bore size, the same stroke, but it's going to have different rod ends on there. So you have to cut these and re-weld those. These tubes right here are not going to be like the original. You'll have a port here and here, and you've got to either modify it with these or get some, you know, rubber hydraulic lines made and get it adapted. And that could have been a route that they took as well. But they wanted to see if we could just fix this one, and I agreed to it and said, yeah, we can make a gland and put it back together. It shouldn't be no issue, when in fact it does. Sometimes you have things that sneak up on you that you don't expect, and nothing to do but just to keep pushing forward and get it fixed, and that's what we did. So I know that they're happy to know that it's ready to go. So I'm going to sign off. I hope you guys enjoyed the video. I always try to help you guys out the most that I can. Remember, if you're needing some hydraulic parts, you can contact CRC Distribution for any of your soft parts, your seals, any of your materials. You need chrome rod, you need ductile, aluminum, honed ID tubing, this hydraulic tube right here, other materials that you might need to make component parts. They have all that stuff over at CRC. So if you guys have your own home shop or garage shop and you've never tackled a cylinder before and you might have a need to do one, give it a try. It's really not that bad. I mean, once you understand what the component parts are and know how to look up seals in the books and how to size them and machine the grooves right, it's nothing to it. So I would encourage you to give it a try if you have a cylinder that needs to be repaired. Even if it's just leaking, you might just need to take it apart, put some new seals in it, put it back together and get it back on its way. So again, I hope you guys enjoyed the video, and we will catch you on the next project. All right, see you then.